Welcome back to the final video in Cocolabs, and today we're going to be putting everything together to build a robot that can pick up trash in the field. So far, we have built the chassis, finished autonomous navigation, and identified trash from the grass. In this video, we will be figuring out how to pick up trash from the grass and putting everything together for our final run. To decide on a pickup method, we first collected data on the grass and trash. We measured the grass to be around 4 to 6 inches tall and relatively stiff. We also picked up trash with Joe Paguaga, the local park maintenance officer, and learned that most of the trash was large plastic light pieces of trash consisting of wrappers and boxes. With this information, we went to the park to begin testing. We're trying different grabbers to pick up trash. This is your standard one. We have this Granular Janitor prototype. We have this fin ray grabber, and we have another regular one. The goal of the test is going to be like our robot, where you position ourselves directly above the trash, close our eyes, and do a blind shrug. Oh, I actually got it. And then we pick up trash this way. First up was the fin ray grabber. It was designed specifically to wrap around objects when grabbing them. In actuality, it just acted as a normal grabber.
All right, go for it. But this one's kind of...
I think it was all wet. That's the whole reason why it caught it.
Next is the normal grabber. It is easy for us to use it and grab trash. Right. Are you recording?
Yeah, sure.
You close your eyes. Oh, I got it.
And partially.
Low.
Okay.
More accurate. Oh, you got it.
Okay, go blind. Wait. However, when blindfolded, it makes it really hard to aim and not suitable for our purposes. Next is the vacuum. Popular pick for cleaning up indoors, it does not perform nearly as well outdoors.
That's right.
And the napkin kept getting stuck.
Can you put it in back? Definitely does not come out.
Okay, so this is the first prototype of a gripper we are trying. So it's called the Granular Gripper Jammer Gripper. So the basic idea is you fill this with granular material. We're using ground coffee. And you put a vacuum through it, so like it's kind of soft right now. And part of the prototype is when I turn on the vacuum, it becomes really hard, like this. So the theory behind this, we'll take a small material. See, so first you place it over it, and then you start the suction, and it picks it up. The granular jammer, while an interesting prospect, does not work well with soft and light wrappers, as they don't have a hard edge to grip onto. Finally is the good old brush and dustpan. It seemed the most promising, as we can easily expand it to cover a large area, removing the need to aim the mechanism. We decided to use this as the basis for our following prototypes. Set it up like here. Yeah. The biggest problem for using the brush and dustpan for our purposes was the height at which we needed to get the trash to. The lip of our robot is 4 inches high. So our first idea was to lift the back of the dustpan and hold it at an angle. The tight trash?
Do it again.
Whoa. I'm not focusing. Okay, go. Keep going. Go. Get in. Get wall. Go up. Stay locked. Just moving the brush back and forth could not get the trash in and up the dustpan. You also needed rotational movement. This proved to be too many moving parts, so we decided to scrap that idea and instead focus on only horizontal and vertical movement using linear actuators and gantry plates. Here is to show off a new piece of technology. It's called a gantry plate. You kind of just slide it on this V-slot and it slides like that. A linear actuator takes the motor's rotational movement and turns it into linear movement. while it is perfect for our uses, it was just really slow. So we are starting the retraction process. I calculated it to be take 2.5 minutes to retract. So we're waiting here for a while. 2 minute 30. Our next prototype kept the dustpan flat, but used 2 linear actuators to move the dustpan up and down and the brush in and out. When a trash is detected, the brush goes out and both the brush and dustpan moves down to ground level. The brush sweeps into the trash onto the dustpan and it raises up, and the brush finally sweeps the trash into the robot. During testing, we found that even after finding the perfect measurements, the mechanism was still extremely inconsistent. I'm gonna pull it if it doesn't pull, okay?
Yeah. That makes sense. No, that's fine. I heard it. What? Huh? By default, it writes to Rio, so then...
No, it's good.
I was dragging a lot. Wait, 1 piece?
2 pieces?
Yes! Yes! This is gonna break. Please.
Leave it. Leave it.
Oh.
No! The dustpan was made of wood and was prone to wiggling, causing it to get stuck underneath the main chassis and break.
I'll tell you when it's ready to go in. Oh, stop. It hit the robot. It's gonna crash, yep.
It's gonna crash, what do you mean?
Oh, crashed.
Yeah. Well, why?
And the H bridge is burning. Okay.
Here. Now look at the wood. Finally, it was just very bulky, doubling the length of our robot. So we decided to continue brainstorming. So this is our new passive pickup design, invented by Keel, inspired by Keel. So what happened here is, you go like this. It's like the robot's driving, right? And it's just gonna scoop it up like that, and it's gonna detect there's trash. It's gonna go up, and then we're gonna have a servo dustpan, and then just like throws it back into the robot. And you drop it again, and you just keep going. And then you see trash again, you pick it up, but you don't need to pick it up because it's smaller than a quarter, baby. So we just keep going, bro. And then it goes like this. And we get trash, you pick it up, and you dump it into the robot. To prototype the mechanism with the proper geometry, we 3D printed a test part. This is our 3D printed teeth. So what happens is PLA is thermal plastic, which means you use heat to melt it.
Dude, I can deform it with my hands.
Look, those dents, that's because the Keel just pressed them in since the PLA is melting in the sun right now. It is slowly but surely tilting downwards. Though it's slightly melted, we still used it for a proof of concept test.
So we're just gonna hand scoop and see if it works. Ready?
Yeah. Alright, that missed 1 trash. We missed 2 trash, 3 trash. Come on, we gotta get at least 1, bro. There, the light one, the hella light one. Yeah, that was free. Okay, we got 1. Oh, here's a water bottle. Here's a water bottle.
Alright, ready?
So this worked.
Yeah. And one of the fingers broke.
Oh, one of the fingers broke. It worked for the target piece of trash, which are the light plastic pieces. However, in testing, it was quite flimsy, so we found someone to help us CNC a stiffer part out of an aluminum sheet.
We're testing this line of trash to see if it will pick it up.
Okay, cool. What's our first piece of trash?
Empty water bottle.
Okay. Oh. Come on, get in there. Yes!
Go.
I swear I'm lined up on the camera.
Alright, stop. Move backwards.
What, were we not on it?
No, it like went down. Okay.
Come on. Yes! No, I think that's too low. The camera says it's too low. Did we go over it?
Yeah. Alright,
Look,
go.
see, so lighter trashes that float on top of the grass, super easy. Super easy. Yeah, baby. Oh, that's a good angle. Yeah, easy pickup. Once we established that it can pick up trash, we started focusing on sweeping the trash into the robot.
So in here we have 3D printed racks that we were able to slide into the T-slot, and then we have gears right here, which are the pinions that are also 3D printed, connected to a Rev Neo 550, which is a brushless motor, and then we have limit switches. So one limit switch here. This is for the switch that tells it when it's all the way in, and then we have a switch in the back that tells it when it's all the way out. So what happens is that's always pressed, and then when it comes out, it depresses, and that tells the computer that it's out.
Here is the entire flow of the trash pickup mechanism.
What will happen is when the trash is over here, so if the brush comes out, and then it'll go up. The brush will push it in, and it'll stay in there.
Once trash pickup was set, we started combining the phases together. We started with autonomously identifying the trash and then picking it up. So we're going to drive forward using this, but nothing else. We're only driving forward. The computer is going to detect trash through this camera, and once it sees trash, it's going to start the pickup mechanism, and it's going to move this pickup down all by itself. I'm not going to do anything on my side, and then it's going to drive forward, pick up the trash, grab it up, and scoop it into here. I think we need to go lower.
What?
Oh, I feel rain. Wait, ready?
Yeah, just keep going.
No, can you move it closer? Oh, it's in a dip. Rain.
Wait.
Rain. Yeah.
It's fine, just keep going.
So, Akil, can you explain a little bit what you're doing?
So when we went outside, the weather forecast said the rain would start in 6 minutes. We thought that was a lie.
The rain started in 6 minutes.
Yeah. So we're blow drying the robot to get it to pay. It's a little wet.
Continue.
With more rain forecasted, we hope to beat the storm and continue testing. Did you get it?
Yep.
Finally, we are ready for our final test. But first, we needed to eat lunch.
Bro, where's our food? I don't know, man. They're taking forever.
I know.
1 hour later.
Oh, the alarm rig.
Give me that.
Took you long enough.
Though the lawn is thoroughly littered, after 2 long years, luckily we have the Cocolabs robot. Hey, get up there, get up there!
Hey! Okay, back away. We need to film.
It's enabled. Where's the remote control? What?
Oh, it did the thing. It's almost like one of those.
So what are you guys doing while your robot's doing work?
We're relaxing. Cleaning up our trash, man. You got it.
Oh! Yes! Wait, hey, it's starting to rain.
No, let's keep running. Let's keep running. We got.
Yeah, it is starting.
All right, so.
Whoa, guys, we realize how fast this can turn, right? Yeah. Hey, you were not here in the morning. It turns immediately.
Okay, someone give like a little caption. Where are you sure the GPS will be?
It doesn't matter anymore.
I think guys are basically done, right?
Get on the car, get on the car, get on the car.
Stop it.
Sounds like the robot is not waterproof.
Alright, power it up. Power up.
Yeah, get it indoor, guys. Get it indoor.
We then submitted this project to 2 science fairs, winning multiple awards, including ones from ACM and IEEE. Finally, I want to thank my 2 teammates, Akil Pathapati and Ayush Gewala, for joining me in this project and working very long hours over the weekends. I also want to thank the multiple adult mentors that helped us in this project, including James Davis, professor at UC Santa Cruz, Joe Pagawaga, the local park maintenance officer, and Yanghua Chu, part of the Waymo project. Thank you so much for watching this video, and thank you for staying with me for the 2 years that it took on this Cocolabs series. As I'm going into junior year, it's going to be much more busier with academic work, but I hope to continue my personal projects, so stay tuned on my channel.